I don't want to drop it. I'm gonna. Shall I leave it here?
Okay, everyone, hello. Welcome to the very first Apache Beam Warsaw Meetup. So my name is Karolina Rosu. I'm project manager at Polydia, and I'm honored to welcome all of you to this meetup and thank Matthias for coming up with the idea of hosting it at Polydia's office. Because it's our first time. So for those of you who don't know what Polydia does, we are a development and design studio, and we are very fond of cloud and big data projects. That's why we actively contribute to Apache projects, so not only Apache Beam, but also Airflow, for example. And for today's schedule, I would like to say that the most important thing, which is pizza, is going to be at the very end of the talks. So please stay with us for the pizza. Also, I would like to ask you to stay focused. Matthias Beitens, so I'm leaving the voice to you. Thank you.
Awesome. Thank you very much, Carolina. And I want to thank you guys, the Polydia team, for making this happen. And especially big shout out to you, Carolina, for putting all your forces behind this. So welcome, everyone. The first Apache Beam Meetup. I'm very happy you guys are all here. How are you feeling? Good. All good? Still energized? Not too long day of work? No? Okay. I'm a bit tired because I flew in this morning. But I'm gonna try and pull through this. Bear with me. But to warm you up, guys, I have a little quiz as well, and to get to know you. So I'm wondering, who knows Apache Beam already? Ooh, that's quite a lot of people. Nice, yeah. I see very enthusiastic people in the back. And out of these people, who knows Google Cloud Data Flow? A little bit less. That's interesting. Okay. Sometimes you get the other way around. So anyone who had his hand up with Google Cloud Data Flow but didn't with Apache Beam, I'm going to explain what the relation is between these two today in a small introduction. But even more interesting, like out of the people that know Beam, who has written some code in Beam? Okay. And who has production pipelines running in Beam? Okay, interesting. Okay, we should chat tonight. Like, I saw some people. Okay, cool. What I'm gonna try to do, so I have my master plan for tonight. I'm gonna start with a technical intro, where I'll introduce Beam, tell you what it does, how it can help you. I will have an overview of a couple of use cases to look at how other people have uses in the industry. And then I'll finish up with a code walkthrough and a little demo to see how this all works actually. But let's, that was supposed to be there in the first place. Let's dive into the technical intro. So I think you're all quite familiar with the tech landscape, but to level the playing field, we'll start easy. So we obviously have Android Beach here, we have the IoT mountains, and we have the web server river, but today we're gonna talk about the woods of data. Cool, and more specifically, the city of distributed data processing. But what is distributed data processing? So imagine we wanna measure the temperature in this room. What can we do? Any suggestions? I'm taking suggestions. You install sensors. That's the right answer. So we install sensors in the room, maybe in some other rooms, and we send some data, so some events, the measurements, to a processing backend. So this is our server that is going to process the events that come off these sensors. But obviously one day your boss is going to come to your desk and he's going to say, we don't only want to monitor this building, but we want to deploy this over the whole country. What's going to happen? you will need more processing resources, right? So what can you do if you need more processing resources? Hmm? You do it separately for each, so you would send sensors from all over the buildings to one processing backend, and then this processing backend, what might happen to it? Different computers. Okay, that you're too smart for me. That is a good answer, but the answer I was looking for right now was actually you just buy a bigger machine, right? So you can add some RAM, you add a bigger CPU, and this is what we call vertical scaling, right? So you buy a bigger machine because you need more resources. So obviously your boss is going to come back to your desk at some point, right? And he says this time, we're not going to monitor the whole country, we're going to monitor the whole world. What should you do this time? Distribute? You should also ask for a raise because your company is doing very well. But exactly, so we have more events, we have the processing backend, but this time we're going to distribute. So we're going to horizontally scale, and this is most of the time done with commodity hardware, so like the normal CPUs and normal hardware you get in a machine. So today we're going to talk about horizontal scaling, not vertical scaling, and that's where you end up with distributed data processing. So pretty cool. You have your processing backend now, and what can you do with this? For example, your events come in throughout the day, and you can process your data at the end of each day, right? So you calculate, for example, the average room temperature on that day. This is pretty cool, I guess. Are we happy? No, we're not dinosaurs. We want something cooler. We want to process the data in real time. So as the data comes in, we process it, we do something with it, right? That is the cool stuff. So everybody happy? Yes, no, everybody happy? Okay, yeah. Not everybody happy? I'm also a bit sad. Like, this is cool, but it comes with some extra complexities, and this is where Beam comes in. So Beam gives you some concepts to think about streaming data. We have a stream of data coming in, we want to process it. Beam provides you concepts to work with it and an API to implement this, this processing. I'm going to run you through some of these concepts, and the first one I want to introduce is the difference between event time and processing time. So we have these sensors installed, and once a data point is sent to your backend, you will attach a timestamp to it, and this is what we call your event time. So when the event is created, that is the time that you call the event time. But obviously, while you're sending this event to your processing backend, there will be some delay because network causes your event to be delayed, or there is no network for this day, it needs to be fixed, I don't know. But what you will end up with is delayed events, out of order events. And the time that your event will arrive in your processing pipeline is what we call the processing time. Everybody still on board? Yay? Okay, cool. So the next thing we're gonna look at is a concept called the watermark. So we have this processing time, so when the event arrives in your pipeline, and the event time, when it gets created. And we want to define a relationship between these two. So that's what your watermark will do. And the interesting thing is, for example, you want to calculate every hour the average room temperature. So you have a bunch of events coming in. You want to average them over that hour. Obviously, there will be a delay for all these events to arrive. So that's what we call, this delay is what we call the skew. So let's say for the hour, maybe 5 minutes later, we're sure that all the data has arrived because of this network delay. So this relationship is defined by the watermark, and the watermark is kind of, from the system point of view, the processing backend point of view, the best guess of if all the data has arrived in your pipeline for that particular hour. All right. So we are looking at this event time, these events are coming in, and we want to calculate some meaningful aggregations, but most of the time these aggregations you want to do happen in event time. And there we introduce a concept called windowing. So for example, every hour we calculate a window of the events, the average events coming in, and you calculate the average over these temperatures. So this is batching, basically you're batching your unbounded stream of data up in different windows. And the next concept is related to when you actually output and materialize the average of this, for example, a certain hour, and this is the concept that we call triggering. So triggering can come in multiple forms. So, for example, if you want to already, for a certain hour, have some calculations before the hour ends, you can have an early trigger. If you just want at the end of when your system thinks all the data has come in, emit a result, then you have the on-time trigger. And for events that arrive late in the system, because that can also happen if your system was wrong about estimating when all the data has arrived, you have late triggers to handle this event. And all of this kind of comes down to a couple of trade-offs. So you want to calculate the most accurate aggregations. So you want your data to be complete, but if you want to be sure that your data is complete for a certain hour, in theory you will have to wait for an infinite amount of time, and you don't want to do that, obviously. So that's where the latency comes in. The earlier you want to have a result, the shorter you can wait. And then at the last stage, we also have the cost we can take into consideration, because if, for example, every minute you output the result of the data you have seen so far, which is going to be accurate to, well, it's not going to be super accurate, but it's going to be already accurate. But it's going to cost some compute cycles to calculate this result. So the more you calculate preliminary results, the more it's going to cost as well. So these are kind of the trade-offs you look at. Cool, so that was kind of the streaming-related part of Beam and some of the concepts that help you deal with this problem. And then the second part that Beam provides is an abstraction of the language, and on the other hand, the execution engines. So let's think about a pipeline that we want to build. So you have some transformations, you want to maybe do a regex, you want to do a multiplication. These are some transformations. You can have some aggregations like an average and a sum. So you have a conceptual view of what you want to build. You obviously want to express it in your favorite language or your team's favorite language. And some teams like Java, some teams like Python. So Beam gives you the flexibility to pick and choose your favorite language. On the other hand, you'll have to execute the code as well. So you'll have to run it on some computer, and that's where the execution engines come in. So different teams are versed in different execution engines, and yeah, Beam can abstract that away for you in a way that you can write your pipeline once for both batch and streaming jobs, and you can kind of run it anywhere. Happy? Cool, okay. So this is obviously a vision, and there's different stages to it, and it is what you can find on the mailing list under the portability kind of section, I guess. But at the moment we have different languages. I think Python is probably quite popular, Java, Go, and there's different runners. So Spark and Flink are, I guess. Who's familiar with Spark and Flink? Okay. So that's about the same amount of people for Dataflow as well. And Dataflow is one of the Google serverless runners that does everything for you, basically. And I've been discussing this with a few people. It's something we said at some point. Take this with a pinch of salt. It's kind of more of a joke, but you could look at Beam as the Kubernetes for data processing, if you want to do a one-liner. I'm going to improve this at some point. But onto the use cases. So what are people actually using Beam for in the world right now? So I'm not sure if you guys are familiar with Lyft. Anyone? Ride hailing? Okay, yeah, cool. It's like you have Uber in Warsaw? Okay, yeah, it's a ride-hailing app. So if you want to have a taxi, then you can like call it, and it will come and pick you up. So what Lyft uses Beam for is in real time streaming some features into a machine learning model to calculate. Probably you're familiar with surge pricing as well. Like if your concert ends or like it's getting busy, there is like a supply and demand curve, and they're basically trying to optimize that through calculating the price in a streaming manner. So they're using Beam on top of Flink, on top of Kubernetes, and are processing 400 billion events per day, which is quite a lot, I would say. Then the guys over at LinkedIn, they basically did something for their data science team, where the data science team want to create some features for their models. But they are not always super keen to write code themselves, so they basically enabled them to give a config, and this would generate a Beam pipeline that then basically sped up their feature generation and their experimentation phase for the data science team. And then the last use case, one of which I was more personally involved in, was one for Sky. Who are you guys familiar with Sky? No? Okay, Sky is like a TV provider. So you have the TV set-top box, and you can like flick through your channels. So basically, what they tried to do was analyze the usage of the platform, how people were using and getting to certain content, and they wanted to get some insights on that. So what we did there, this is kind of a more deeper use case. Basically, the events that were coming off the set-top boxes, they went into PubSub, Google Cloud PubSub, and then went into a Google Cloud data flow pipeline running Beam. So there we did some sessionization, which is a certain form of windowing. We also took their reference data, which contained like more metadata on their content, and we loaded it to BigQuery, joined the two things together to enrich it. And then we did a second pipeline, which was a batch pipeline that kind of went to look at the sessions and analyze them. Results went back to BigQuery, and then at the right side, we had different kind of users of the data. So the first group we called the advanced data users, because they were basically consuming the results of this processing pipeline, which was sessionized data, but still raw. So they had to write their own queries, but they also benefited from the event streaming in, so it was the latency was super low. Then the second group of users were the normal data users. These guys benefited from the data coming from the enriching pipeline, which was already had some pre-calculated metrics, but they still had to write their own SQL in BigQuery to get some results. And then the last group of users were the dashboard users, and they basically came in the morning, they have their dashboards, and they can answer the questions they have. And inside this whole thing, we used Airflow for scheduling, and then Stackdriver for the monitoring of the whole system. And yeah, Sky was happy, so they basically went from an on-prem Hadoop system to a serverless Google Cloud Dataflow system that was running their data analytics pipelines, which auto-scaled, cost less because you pay for what you use, because basically, if you look at usage of TV, it spikes at night because you come home from work, there's a spike, there's more events getting generated, and when they had the fixed cluster, they basically had to provision for the peaks of usage, while with Dataflow it downscales when there is less usage in your system. And another cool thing is the dev and the ops just lasted way less long. All right, who's ready for the demo? I'm not sure I am. So this is where I get a bit scared, but I brought some swag. So if things go wrong, I hope you're not too hard on me. Cool. So what I want you guys to do is grab your phone and go to this link. And I just also found out that Bitly is case sensitive, so you need to have the big B and the big D. That sounded more weird than I thought. So bit.ly/beam-demo. And once you land on that website, you should see a form. Did you guys get there? This is my best front-end development skill, so yeah, it's not gonna get much better than that. So what I want you to do is submit a sentence in your favorite language or the more exotic languages we get, the better, so go crazy. And while you're doing that, I'll talk you through what's gonna happen. It's basically a very similar architecture to the one of Sky. So you guys are over here on your phones, and basically the website you see is some 3 lines of HTML and a Node.js backend running on App Engine. Once you publish a message, it will go to Google Cloud PubSub. It will get picked up by Dataflow, which uses the Translate API to infer the language in which you typed your message. Results get written to BigQuery, PubSub, and then Cloud Functions picks up the messages in PubSub and writes them to Firebase. And the Charge.js part is the part I'm now going to show, and hopefully everything went well. Cool. So we have English and Polish already. I'm going to add a bit of Dutch as well. Awesome. So let's look at what we have. We have a lot of, obviously, Polish in the room, and a lot of English. Some Ukrainian, I guess that is. Someone from Ukraine in the room? Yeah. All right. Nice. So basically what happened, all the messages came into the PubSub system. They went through Dataflow where we had fixed windows of 1 minute. So every minute we look at all the events that came in per user, per language, sorry. And then we count the number of messages that came in for that language in 1 minute windows. And this should update now every minute. So if we wait a bit, there we go. Less messages, but you guys did a great job. Applause for you. Awesome. Okay, so we can take a quick look. I think I have a few minutes left. Okay. We can take a quick look at what it looks like in Dataflow. So this is basically what you would see when you fire up a Beam pipeline on Google Cloud. So your runner in this case is Dataflow. And you guys have added 721 messages, so thanks for that. That's super great. There's a few steps it goes through. It decodes the messages. It makes a Python object out of them. It detects the language, so it does a call to the Translate API. In the middle, we are just writing to BigQuery, and on the left is actually the results you saw. So we extract we make a tuple out of the language and the message. We assign the fixed windows. We group by key, so that the key in this case is the language and the window. And we count the number of languages per window per language. And on the right side, I do something more user-related, where I sessionize. So anyone who has submitted messages, it will also calculate sessions. So a certain time of inactivity will cause a new session to happen. That's a special kind of windowing. We can also look at the results in BigQuery. So let's run this query. We have some Spanish. A lot of Spanish. I need to make this. I need to put an extra filter in there, I think. Where is pizza? Okay, pizza is coming. Nice. Okay, so this. Oh, we can also look at the code. So basically, the graph you saw, I coded the graph up in Python, and basically what you have. Can you actually see it, or is it too small? Too small? This better? No? Ah, where do you do that? I like that.
The last one, all the third from the end.
Third from the end. Oh, sweet. Thank you for that. I learned something as well today. Yay. Okay, I'm gonna use this in my next talks. So yeah, basically, we have the pipeline definition. I'm just gonna stand over here. So we have the pipeline definition over here. We have the P collection of events that we do operations on. So we read from pub/sub, we decode, we parse the message to a log, which is a Python object. And then I'll show one example of a transformation in which we actually do the call to the translate API. So, boom, there we go. So basically, you just define the function that you want to execute on each and one of your elements. So in this case, we have a translate client, and we detect the language and output an enriched event. How do I exit presenter view? Is this like Vim? No. Escape not working? Awesome. Ah, I got it. That was close. Oh yeah, I did. Live coding. Yay. All right, so we can look at a bit more code or chat after. I'm not going to bore you to that with showing code. So let's wrap this up. Cool. So I went over all of that. So what did we see today? We saw some of the technical concepts, we saw some use cases, and we saw a super awesome demo that didn't go wrong. Yay! I want to send you home with some resources in case you want to learn more. So Beam has a website. We have a summit as well in case you are interested in attending more events. There's a YouTube channel on which actually all of this will be live streamed or is being live streamed. There's Twitter you can check, mailing list you can sign up to, and there's 2 great blog posts that I recommend you reading if you're getting like your toes wet right now. And then if you want to reach out to me, you can do that as well. Thank you very much.
All right, so I would like to invite to the stage my fellow Polodians, Kasia Kucharczyk, Łukasz Gojowy, and Michał Walenia, who will speak about quality assurance in Beam pipelines. And just 2 minutes for setting up the computer. And just one more thing, because I forgot to let you know that there will be a Q&A, but during the networking time, because we have limited period of time at the moment for presentations. So you can talk to the speakers after all of the talks.
Piłota, nie wiem czy chcę. Jak wolicie? A wy chcecie pilot? Działa. Okay, I think we can start, I guess. Okay, hi and welcome. As Carolina mentioned, I'm Kasia, and together with Łukasz and Michał, we're gonna talk about quality assurance in Beam. So as you can see, this presentation is divided into 3 parts. First of all, I will tell you about the goal and why testing in Beam is challenge. Then Michał will tell you about testing framework and some toolset for testing. And finally, Łukasz will tell you about some real-life examples using this toolset. Matthias explained that probably very well, so I will just quickly remind you about how Beam actually works. So Beam uses this unified model that you can, with that model, write your pipeline in the language of your choice, and you can write the streaming and batch jobs in it. And then you can perform it on the processing engine of your choice also. When you look like deeply and with the examples what you can find there, you can find those languages that there are like SDKs of Java, Python, and other languages such as Go. And you can use some externals. So you can connect to Cassandra, you can connect with JDBC databases, etc. And you can switch between various runners, such as Flink, such as Spark, or Data Cloud. And when you think about testing that, because as you can see from this diagram, it's quite complicated. And first of all, what probably comes to your mind is unit testing. So with unit test, you can test pretty much the basic things from each SDK. So if all the mechanisms are performing well, everything is okay. And you have to probably then mock everything what is from the externals. So you don't know actually how those externals are going to work with your pipeline. And that's why this is important also to have in Beam integration testing. So with integration tests, you can set up all those externals, and you can check if your pipeline is working correctly with that. Also, this is quite important for every client and the user of the Beam, because like, whenever you think about the pipeline that suits you, and you want to check if it works with your database, you can like write this test and use some toolset for that to set up infrastructure. Also, important part of the testing is performance testing. So it's important for developers of Beam because you can easily check if there's any regression during development. But also people can compare, like maybe this runner performs better than the other one. Maybe a pipeline written in Java is better than in Python. So this is quite nice for everyone to compare how everything works together and what is the performance of it. So when you've got these tests inside of Beam or the test that you provide by yourself, you can be challenged by several stuff. So first of all, you have to generate somehow data, and you have to know that with every test run, that this data are going to be the same. It means that whenever you perform your test, then you get the same result. And this is very important for you to know that, okay, everything works fine and those tests are not flaky at all. Secondly, it's very important to isolate those tests. So, for example, you don't want to have a test that works like simultaneously with the other JDBC test and write to the same database, and then your test became flaky and like rewrites every data in your database. So that's why you want to have tools that can help you with isolating that. You would like to have something that's gonna set up all this environment for you and tear it down. And this is very important that, for example, when you set up some services in the cloud, you want to clean after yourself, because then you're gonna pay just for it. So this is also very important, and you need also tools for that. Also, when you think about the performance, you would like to somehow measure everything. You would like to know how long takes your pipeline how much time takes your pipeline to run. Or do you want to know what's happening inside your pipeline? You want to observe it from the inside. So you need some tools also for that. And whenever you collect that information from your pipeline, you want to present that to other users so they can compare it. And you want to show these changes of performance, etc. And finally, when you've got all of those tools, you want to somehow manage that. So that's why our team decided to create such toolset for Beam community and also for other users that would be easily set up the whole infrastructure for the test. It will be easy to measure everything what is going on in Beam, and also automate all of that stuff. And details about that will tell you Michał.
Okay, hi. So as for infrastructure, let's start with one of the tools we're using to set up the test infra we connect to, and this is Kubernetes. Kubernetes is a Docker container orchestration engine and tool that takes configuration in form of YAML files. And as you can see on the screen below the logos, it uses just one-liners to create, for example, a Postgres instance, and also a one line to delete it. It is quite flexible. It can connect to both cloud providers. In our case, this is Google Kubernetes Engine. But also it's possible to set up Kubernetes on-premise and on a development machine using tools like Minikube. A great advantage is also that Kubernetes clusters are isolatable, so the isolation problem Kasia mentioned is mitigated. If we don't want to use Kubernetes and containers, for example, if we want to set up a Flink cluster with some Docker in Docker containers, we use Google Cloud Data Proc. This is a managed service that is designed mainly for running Hadoop and Spark workloads, but it's also configurable using special scripts called init actions. We contributed a set of scripts, a set of those init actions to the Beam repository, and with them it's possible to set up a Flink cluster also with one line, and it's easy to configure the number of workers, Flink version, if you want to use a portable worker image or not. And tearing down the cluster is as easy as running one command. Currently, we committed into the Beam repository several scripts for Kubernetes. So we have a Postgres instance, Elasticsearch, Cassandra, a Kafka cluster with a configurable number of nodes, MongoDB, HBase, and an HDFS cluster. And for Dataproc, we have a configurable Flink cluster, and we're planning to add Spark support. But we're really not sure if it's going to be on Dataproc or on Kubernetes. We will see about that. And now, when it comes to measurements, we're using an internal tool of Beam called the Metrics API. When we started working on Beam, the Metrics API was only internal, and it was difficult to use metrics to observe testing pipelines, so we added some wrappers to the metrics. This is an internal Beam tool. There are three types of metrics: counters, gauges, and distributions. And as you can see, the one Java line adds a time monitor. The monitors are our wrappers we contributed to the code. And this one line gathers start time of an Avro pipeline. The great advantage of metrics is that they measure only internal Beam operations. So we don't need to measure the time of Jenkins jobs because they also include pulling of the code and staging to Dataflow or wherever. We're just measuring the internal Beam operations, so we have the exact time stuff takes to happen. And after we've gathered the metrics, we report them to Google BigQuery. This is a database, and it's okay. It stores our metrics quite nicely. We visualize them into graphs you see on the slide using Perfkit Explorer, and we organize them into dashboards. And we do it like this right now, but it's not an ideal situation. The dashboards are cumbersome to use and create, so we need to manually make dashboards for every type of test and every type of metric. And BigQuery is an okay database, but there are some better tools for the job, and this is why we proposed a metric visualization improvement proposal. When it's accepted by the community and when it's implemented by us, we are going to be using InfluxDB with Capacitor for storing the metrics because Influx is a time series database, so it's automatically better suited for storing this type of time-related stuff. And we're going to use Grafana for visualization. The advantage will be that thanks to Capacitor, we are going to have automated anomaly detection. For example, we're going to get emails for the dev list or build list when there are some regressions or when the tests start performing not as ordinary. And now to automation. For running the test jobs, we're using Jenkins, using Apache Software Foundation infrastructure, and about 16 instances of GCP workers handling our testing workloads. We have Jenkins job definitions committed into the code base, so it's the jobs are also defined as code. We introduced several bash scripts that are used on Jenkins to create the infrastructure I mentioned using Kubernetes and Databrog, and they can also be used by the developers to exactly replicate the infrastructure we're using on Jenkins. And everything is also connected to GitHub, where all the code is hosted. And we have a cool thing, a plugin for Jenkins, which allows for phrase triggering of Jenkins jobs. It means that in order to run a test or a suite of tests, I only need to comment on my own pull request or on somebody else's pull request, and the tests are automatically started and the reports are connected to the pull request. To sum up, we have, this is the diagram of the testing toolset we use and we contributed to Beam. We have Jenkins jobs with GitHub integration. We have external infrastructure set up by Kubernetes and Dataprog. We have various runners, Flink, Spark soon, and Dataflow, and test code is executed on those runners by Beam. And we gather metrics using Metrics API, and hopefully when everything goes well and our proposals are accepted, they will be reported to InfluxDB and visualized in Grafana. It will also be much prettier than the graphs in Perfkit Explorer. And now here's Łukasz for some more real-life examples.
Thanks, Michał. So we showed you our goals. We showed you our infrastructure that we use to set up all the necessary pieces that we need for testing in an integration and performance way. But we didn't show you what we actually do in Beam, the core of our work, meaning testing. And there are actually two major types of tests that we do. I'm going to speak about the first one right now. So this is I/O testing. I/Os, as you can remember from previous presenters, are those pieces that you use in Beam pipelines to connect to a database to either read or write data. So this is, as you can imagine, really crucial so that they perform well, so that they read correctly and write correctly. So this is, ergo, this is crucial to test them. So we test them and in two ways, in an integration and performance way. And what we actually do is that we take those I/Os and test interactions between them, the runners, and various SDKs. So for instance, we currently run those tests, well, mostly on Dataflow Runner, but we have some stuff developed for Flink, so you can expect them being run on Flink soon. And we run some tests on Java SDK and Python SDK. Those are real data store instances, real runners, and it's about 20 jobs running daily and checking correctness and performance of I/Os in Beam repository. If you're interested for the deep guts of that thing, there's the proposal we've sent to the community some time ago. There are the details, there's also documentation about that. But in a nutshell, this is a text I/O integration test. The most basic I/O that you can find in Beam, it reads text. This is like the basic form of data that you can send to the pipeline, right? So what we are doing in such test is that we are writing some data, generating that using a generate sequence transform that is available in Beam. We are producing some text lines, we are collecting the metrics, this is something Michał told you about, and writing the contents to a series of files. Then the next part is reading that stuff. This is pretty straightforward. We're just getting the files getting the text from the files. And what we are doing next is that we are calculating a special hash code for all the elements in a P collection in the pipeline. So all the records that we have in the pipeline, all the events are merged into one hash code, and we compare that with a pre-computed version that we have, that we checked that is working. And this way we're checking correctness. And we are detecting regressions. For example, if somebody has introduced a change to Beam repository that breaks correctness of the text I/O transform, we will know that thanks to that assertion that is below. And where's the framework that we told you about? Well, it's here. So we have some Kubernetes containers set up for, in case we want to run that test on HDFS file system, we are spinning up an HDFS cluster this way. This is available in Beam repo. We are doing that one-liner command, and we're good to go. We can run the integration test. If we want to spin up Flink Runner, we can use the dataproc instance and spin it up, run the test, and then tear down all the infrastructure. Metrics currently, as Michał told you, are stored in BigQuery, and we have a dashboard on App Engine that shows everything, every results from the tests that are run on a daily basis. And orchestration, this is also pretty straightforward. We have Jenkins and GitHub, and if somebody contributes some code, and for example, I'm reviewing that code, and I'm not certain if that code doesn't break the performance, I will probably type a comment like this, and if the performance is worse, I will probably tell that in the code review. So yeah, not only me, there are also contributors doing that on a daily basis. So those are text I/Os, and yeah, those are the results that I wanted to show you. As you can see, we ran the test on 2 file systems using 1 gigabyte of data. That's something, I guess. And this is GCS and HDFS file systems. And we don't have perfect isolation yet. This is why there are ups and downs on the way. But in general, we are able to see whether something has gone drastically wrong, because those graphs would go all the way up. So those are the text IOs. Now I'd like to skip to some other part of work that we're doing, and this is testing core Apache Beam operations. Here we don't focus on the correctness. We have other tests for checking correctness in that case, but we focus on performance only. And what we are doing is that we are creating stressful conditions for the most basic pieces in Beam. For example, group by key operation. You probably wouldn't be able to write anything without group by key transform in Beam. And co-group by key, pardo, and combine, all those things are super crucial. Those are the core things in Beam model. We are not using data stores here. There's no need. We generate this synthetic data using our special IOs. And we do that for Java and Python SDKs. And those tests are running currently on Jenkins using Think and Dataflow runners. It's about 14 of them. An example of such a test would be performing a fan-out operation on a group by key transform. That means that we have two pipelines run, and first we run the test that fan-outs 2 gigabytes of data is copied for 4 branches, and then we do the same for 8 branches. And what we observe is that it takes, for 16 workers that we use, it takes the same amount of time to run such operation. If that wouldn't take the same amount of time, that would mean that some branch got stuck, and this is something that needs to be fixed in Beam for the Dataflow runner. And so yeah, this is the group by key example. But we can measure other things. We can, for example, measure what is the metrics API overhead itself. Metrics API can be used by other users, not only by the team that tests. Anyone can have metrics in their pipelines, and sometimes people tend to put too many metrics, measure too many things, and that can blow up your pipeline. That can actually harm your performance. And we are trying to measure to what extent we can use the metrics API in order to be safe. So what we're doing is that we have a special doFn operation. That's the basic building block of Beam. And we have a bunch of counters inside, and we can either set, let's say, 10 counters and increment them 10 times, or 1 counter and increment that 10 times, or 100 times. We can parameterize that as we want to. And this way, after comparing those two pipelines, we can see the results, and we can see that if we, for example, use 10 counters, we use 1 counter and increment that 10 times, that takes 23 seconds. And if we, for the same amount of data, for 2 gigabytes, if we do the same, but 100 times, it will take 34 seconds. So that gives us some kind of proportion, and we measure that for Java SDK in that case, but we do that for Python SDK as well. We can do the same for Flink runners. So yeah, so we can do all kinds of testing. So those are the examples I wanted to show you. There's a whole lot of different operations that we test. This is just a tiny bit of what we do. So we're testing IO transforms, we're testing core Apache Beam operations, but remember, thanks to all the infrastructure, all the toolset that we created for Beam, you can take all the pieces and set up your own tests. There are, for example, other tests already utilizing that. For example, Nextmark. There are also validates runner tests in Beam that can be used. And you can write your own kind of tests. For example, if you want to check how many times files are copied, or other kinds of situations that may affect your performance or correctness of your data processing. So to wrap it up, we had in our team some goals to fulfill. So there was not many infrastructure to actually set up the sophisticated tests like we do. So we contributed that in the form of the testing framework, or as we used to call that in this presentation, the testing toolset. And we have integration and performance tests that can be used to actually validate Beam, to actually detect regressions, to actually check how much time does it take in order for everyone for Beam wants to be transparent for everyone in terms of its correctness and performance, so you can use it as you please. Thank you. We are from Polydia. Those are our Twitter handles, and I don't know if we have time for questions. No. Okay, so you can always catch us after the presentation, the next presentation. Thank you.
Thank you, guys. So our last speaker is Wojn Katic, and he will speak about TFX for machine learning. So welcome on stage.
Test. Yeah, thank you. Is it on? Test. Yes. Okay. Yeah, that's okay. Just see. Let's start from here. Hello, everybody. My name is Wojn. I'm a software engineer at Google, and I actually spend, I would say, 10 hours a day thinking about Beam and how to make it better, and also GCP. I am focused on security and privacy, but we frequently find other issues that need our attention. So I would start with this title and just explain each of the parts here, right? So for Apache Beam, I think as an open source project, it's very important to have community, and we really appreciate what Polydia did today and your interest in this, and this kind of stuff is something that decides the future actually of open source projects, right? For machine learning, I think the keyword here is production, because you have to worry about this kind of stuff only if you want to have a system that's going to be used for a longer period of time. If you're just trying to figure out if you can get the model to learn something for like a day or something, then logic is quite different. And you don't have to worry about many problems. But what you learn once you get the model and then try to use it for some time or like get some performance from it and anything like that, what you get is that all the logic around the model itself gets more and more complex, and it's trickier to debug what's going on. And in some statistics, only about 10% of the code ends up being spent on the trainer to get the model. Everything else goes before that and after that. So what Google did is we had like 20 years of experience with this kind of data processing and machine learning, and TFX is our latest idea of how to generalize all the knowledge we have and how to get one framework that's going to make this whole process more reliable and stable and in any other way better from both machine learning and software engineering point of view. So there is a long history of how we got to this, and in every other company, you start with some simple idea, like I want to have a linear model for something, and then you build all the stuff around it, and then at one point you figure out, oh, I would like to try with neural network, and let's see how it goes, and then you understand that actually there's so many dependencies that you have to change a bunch of stuff around that. Good thing about TFX is it depends on one of the components is TensorFlow, and TensorFlow is very flexible. So it solves that problem, that it doesn't put any pressure on you on what kind of algorithms you want to use for actually creating the model. What it did for Google is it, I think, made the whole thinking about how to become a AI company much different, much easier for people working on different projects, for people switching teams and so on, because it's uniform, and once you learn it, you can apply it everywhere. And we also saw that our partners can do the same thing. So my goal today is to introduce you to this so that you can see all the benefits of it. So Beam, I think everybody already explained the main points. I think portability is probably the key thing that we thought about when we were designing it. And then later on we figure out, okay, we can improve security, we can improve efficiency, we can improve many other things by investing in this software, right? So I think previous presentations covered the most important point about that. This is just a slide to show that in Google, in my team, we think first about Beam and how to make that better and how to make that more flexible for you. But then the second step is we think about GCP, in this case Cloud Data Flow, and how to make that the best, the most efficient runner so that you actually choose it and see the second part of our work at work. And it's very useful component for TFX, because being this flexible means that TFX could be applied in different scenarios, in different companies and so on, which is a good thing. Yeah, so as I said, for production machine learning, one side is data, and people who are thinking about this, they always start thinking, if they do like supervised learning, they think about label data and all the other aspects, like fairness. Then if you do if you cover some very risky, let's say, medical tests and so on, you want to cover rare conditions and so on, you want to make sure that you get that aspect right. But once you get the model and you start using it, you learn that there is a second part, and something that we as software engineers learned a long time ago, and that's that you need to make sure that you can maintain it. You need to make sure that it's safe, that it respects privacy. You need to make sure that it's testable, right? You have to get some visibility in what's going on, because data changes, right? If you think about Google and search, stuff that people post online and the way people use search these days is different than, like, not to talk about 10 years ago, it's different than a month ago, right? Topics are different, everything else is different. So being able to track how this system evolves over time is very important, and that's why TFX is there to help with that. There's this great paper that covers some of these points. So if you are still unsure whether this is the right tool for you, I recommend reading this and figuring out what are the problems that you can solve right away by thinking about the bigger picture and not the trainer itself only. Cool. So this is very frequently used schema of all the components that good machine learning system should have. And what we did at Google is first internally we built each of these components many times, right, in different ways. And then with TFX, we decided that we should find one general implementation for each of these components and then open source it, right? And right now, these are all the components that are open source and part of TFX. And I think in the last slide, I'll share some links so that you can get more info about each of them and how to use them and how they work and how they're evolving, because the whole system is changing, right? So if you think about it, I think in September or October, there is this new version of TensorFlow 2.0, which completely changes the logic and how we want to make it more easier for new users to use it, but then also more efficient for experienced users and so on. So TFX is evolving together with TensorFlow and the whole process. I already talk about importance of these components for Google. And in Alphabet, we have several companies. Each of them is using TFX, so we do heavily depend on it and want to make it better. And these are some of the projects that depend on TFX right now. The list is very long. I just picked some that are most famous one, right? And there's this web page where you can read about other companies. We heard today about Lyft. There's also PayPal and others who posted their articles about how TFX helped them in getting better performance out of the data and systems. I strongly recommend before you consider to apply this system in your companies to read just the cases and issues they had, how they solved them, and so on, and what kind of results to expect. Cool. And now the role of Apache Beam in the whole system. So here are some of the components in blue that actually use Apache Beam as part of TFX, right? So if we go through the list, we see that beside trainer, which we said is TensorFlow itself, and pusher, which deals with how we can get this data to be served to users, right? Everything else does utilize Beam in some way. So that's why we have basically weekly meetings with TFX team and discuss how to support them in the best way. It's very important for us that TFX is successful, and it's very important for us that Beam is the right tool for them to use in all of this. Now, I mentioned that these things are components. I would like to explain what do we mean by that. Every component has these three parts: driver, executor, and publisher. Executor is the most important thing, right? Even if you write your own component, you will rarely worry about driver and publisher. What you want to focus on is executor. And I will show you some code in these slides, but I think the main idea is figuring out what was the purpose and what's the idea behind all of these components, parts, more than just the code. Code will evolve and change. Here's an example of when you define this pipeline, you will provide configuration for each of these components, right? And one example is model validator, which is actually a component that chooses if the new model is any better than the previous one, right? So what we need is this place where all the models are stored, and in TFX we call that ML metadata. It's excellent library for this kind of stuff. And model validator would pick the last validated model from there. It would take the new model that you just produced. It would compare them and then decide is the new model better and should it be used now in production or not. This is just a context, so it runs after trainer where it gets the new model and before pusher that's going to send this to serving. As I said, executors are the thing to worry about, and Beam being used as a right way to implement this logic. This is just to show the flexibility, right? So you can think about this running on Dataflow, Flink, Spark. If you're testing something, or like if you, for any reason, want to run this locally, there is also local runner. So it's very flexible, and it's all is open source. So if you have any other idea that could make this better, it's very easy to implement that. And also in Google, we actually really like to hear new ideas. And like if you can change our API in some way to make your idea possible, there's very high chance that we're going to do that, or help you do that, because it's community driven. So I encourage you to do that. Just one example of executor, right? This one is for generating statistics based on a batch of data in the pipeline. Yeah, as I said, code is less important. I just wanted to show how easy it is to do. Just basically we read from TF record, we do some statistics, and then we write to TF record, and like in 20 lines you get the whole logic there. So for trainer, what Executor is actually running the TensorFlow and the model itself, right, to produce the model. But if we think about pusher, then there is no need for Beam, for example, right, because it just takes the model and sends it to serving. So in general, this can be any Python code that you need to run for this component, whether it's a component that we already define in TFX or some of your custom components that you can use in the pipeline, depending on what you need. This is an example of the pipeline itself, right? So each of these components are listed there and some configuration for them, and then we use Airflow to runner to run this. So if you think about this whole schema, which is ordered to be the same way as we show in this initial schema how ML model should look like, we see components that run before trainer, right? And I'll go into details of some of those, and then components that run after that, and we'll cover some of those also if they're interesting. So first thing is example again, which is going to take the input from any kind of source you have, right? And basically create a batch of examples, a batch of data that you need, records. After that, we have these three components: statistics, gen, schema, and validator, where I think that first two are interesting for us because they use Beam. So for statistics gen, unfortunately this is a PDF, so all the animations are static. But let's say we go with mouse and select different options and we get some results, right? But the purpose of this component is to provide you more insights into what kind of data you actually deal with, right? And that can help you because maybe data is corrupt, and you know that if garbage is coming into the system, then garbage is going to get out of the system. So maybe you want to prevent that. And so in this kind of sense, having better visibility and insights into your data is going to be helpful. Then schema gen, which is important for the next step, transformer. And this shows how flexible this is. If you think about transformer, it's actually a component. So here's one example of result of schema gen. Transform is actually capable not only to transform data so that you get some feature engineering there, which is something that everybody needs for their model, but actually it can change the whole graph that's going to run in TensorFlow. So you can adjust that to what kind of data you have, which opens a lot of possibilities. Okay, and then after we get the model, we can run evaluation to see what kind of results we got. And this is useful because I'll show you the tool. Here you could select. Let me see. Let me see if I have some graph. Just want to see. No, I don't. You should be able to see how this model performs in different chunks of data, and see if you maybe covered all the rare cases you worry about, and if you have any other issue with the model that you would like to address. And then after that, there is a validator, which is basically the last step, and your last step to prevent any kind of bad model from getting in production, right? So it includes whatever logic you want to attest that this model is the thing that you want to use going forward. So again, here is the whole slide and all the components that use Beam in it. And I just wanted to say that in the whole system, next to efficiency and flexibility that is there, as we evolve all these components, what you get behind that is all the other system, all the other parts, attributes of a software system that are important. So like security and privacy, which I focus on. People don't realize that like there's always a weakest link, right? And that thing determines how secure your system is. And by making this standard set of components in the pipeline, something that we can pay attention to, it makes the job easier for any changes that happen going forward, and like figuring out what is now the problem, and like if you want any new way to use the pipeline, any new credentials, anything like that, how to make sure that all the parts cover it in the right way. Okay, so here are some resources. The first one is for TFX in general. The second one, some tutorials and examples of use cases. And then third one is for Beam and its role in TFX. I want to thank you for your attention. And any questions you have, I guess we'll do it after the talk. Thank you very much.
Okay, guys, I don't want to keep you any longer because pizza is here. So if you want to, it's not working. If you want to take part in the quiz, then we'll do it after the pizza, I suggest. Yeah? Okay, so let's eat.